Hey everybody, it's Miss Mary, and today we are going to go over section 1.3, which is called the process of a statistical study. We will get maybe a couple more definitions in this section, but we are wrapping up um, chapter 1 today in this video, and we are sort of coming to the end of our time that we're going to be spending going over vocabulary stuff. So let's get started. Let's talk about the process of conducting a statistical experiment. We've got it broken down here into 4 steps. The first step has been sort of broken down even further. So it says number 1, design the experiment. I mean, this is super general. So we're just saying design the experiment. Experimental design is something that you could study for years. They have whole classes if you want to go to graduate school for anything like psychology or for nursing or, any kind of social science, you will have to learn about experimental design. So within experimental design, we've got that broken down further. You need to start by stating the question that you want to study, and here you are really boiling this down to its most simple form, so its most succinct form. You're stating the question, figuring out what your population is, who are the people that you're interested in studying, and what are the variables that you want to collect. So what are the different questions that you want to ask? How should you be asking the questions so that you don't introduce bias? And then based on steps 1A and 1B, you're going to figure out what type of study are you going to be conducting, an observational study or a designed experiment or an experimental study. All right, so let's define each of those. An observational study is just where researchers observe characteristics and take measurements. So think survey, i.e. a survey. All right, so an observational study is just where you are going out and just asking people questions. So maybe you figure out what your population is, what questions you want to ask them, then you go out and ask folks those questions. All right, an experimental design or an experimental study is going to be where researchers impose treatments and controls. We'll talk more about those in a little bit. Impose treatments and controls, and then observe characteristics and take measurements. Try that again. All right, then observe characteristics and take measurements. A good example of something like an experimental study would be like a drug trial. So imagine a bunch of doctors and pharmacists, nurses are testing out a new medication and then observing whether or not it has the desired effect or if it has any undesirable effects. All right, so observational studies, this is just where researchers are observing sort of natural phenomenon, characteristics. They're just observing characteristics and taking measurements like through a survey, whereas the experimental studies are where researchers are imposing treatments and controls and then observing characteristics and taking measurements after imposing those treatments and controls. So like a drug trial. The second step in the statistical experiment is to actually collect the data. And we're going to talk even further about this. This is where in a little bit you're going to see, we're going to talk about sampling methods. So this is where you would decide, okay, what kind of sample am I going to select? What type of sampling method am I going to use? How many people am I going to sample? And then you're going to go out and collect that data. All right, so we'll talk about those sampling methods in a few minutes. All right, third step in the statistical experiment is to organize the data. And this is very, this sounds short perhaps, but this is very involved. So this is where you're going to be putting your data in Excel or whatever you're using to analyze the data. So you're, let's say, typing or inputting the data. So you're typing the data into Excel. Maybe you have some kind of equipment where it's automatically putting that data into Excel. Then you would have to go in and make sure that all the data looks correct and organize the data into, you know, the appropriate columns and rows. All right, so this is going to be where you're typing the data into Excel. You are calculating those descriptive statistics, and then creating displays of the data, which will help you identify trends that are present in the data set. Right, and the last and final step in conducting a statistical experiment is to analyze the data to answer the questions that you set out to answer from step 1, part A. So this is going to be those, this is where you're doing like your statistical test and other inferential statistics. All right. So let's talk about your different sampling methods. All right, so simple random sampling, this is the most basic type of sampling that you can do. All right, so sometimes people get this one mixed up with other sampling methods, but what I want you to think about whenever you hear simple random sampling is this is the most basic type of sample. All right, this is where each member of your population has an equal chance of being selected. All right, so think of this as drawing names out of a hat. So imagine your teacher takes the whole roster of students, cuts those names up, puts them in a hat, and draws out 10 names. All right, so each member of that population, each member of the class had an equal chance of being selected, and it's just totally random. Okay, so some examples. All right, so one example, this is sort of a more technologically advanced version of drawing names out of a hat. So you could select 50 CCGA students by randomly generating their 920 numbers using some type of computer program. All right, so putting in all of the 920 numbers of students that are currently enrolled at CCGA, say into Excel, and then having Excel randomly generate 50 of those 920 numbers. All right, so that would be an example of simple random sampling. All right, next we have stratified sampling. Stratified sampling and the one we're going to see next, which is called cluster sampling, are very similar. So I want you to pay close attention to the differences here. All right, so with stratified sampling, this is where your population gets divided into subgroups, which we call strata, and those strata typically share some kind of similar characteristics. Once you've divided the population into those subgroups called strata, samples are taken from each stratum. All right, so a stratum, this is just the plural of strata. Don't let that word mess you up. All right, so the way I like to think of this is like, imagine you have, um, at Brunswick High, say, and we're just looking at senior homerooms. All right, so maybe let's just imagine we have 10 senior homerooms. We'll call them Miss A, Miss B, Mr. C, D, E, F, G, H, I, J. All right, so imagine each one of those letters is a teacher's homeroom class. All right, so we've got our population, which is our seniors at Brunswick High. We've got those divided into subgroups. All right, so each of the homerooms, let me switch over to my laser pointer. I don't think you can see where I'm pointing. Each of these little homerooms is a strata. All of them together are called stratum. Okay. Once I've divided my population into subgroups, which I've already done, I'm now going to take a sample from each stratum. So maybe I then go to each homeroom and randomly sample, let's just say 3 people from each homeroom. How many total people are going to be in my sample if I do 3 people from each homeroom? There's 10 homerooms, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 people from each. That means I'm going to have 30 people total in my sample. All right, so stratified sampling. Break it down into subgroups, sample each subgroup. Here's an example. You divide the population of all CCGA students into their class level, freshmen, sophomores, juniors, seniors, and then you randomly select 10 people from each class level. All right, so very similar example there. All right, so let's look at cluster sampling, which, like I said, is very similar to stratified sampling, so I want you to notice the differences between the two. All right, so cluster sampling. It's going to start off the same. You're going to divide your population into subgroups called clusters. Oftentimes, these clusters are based on geography, so think like maybe you split it up into all the counties in Georgia, or some other kind of natural grouping, like I'm about to show you. Then entire clusters are randomly selected, and all members of those chosen clusters are sampled. All right, so let's redo our last example. We've got our senior homerooms at Brunswick High. Senior homerooms. We've got those 10 homerooms, A, B, C, D, E, F, G, H, I, J. All right, now last time when I was doing stratified sampling, I walked by and I went to every single homeroom. Okay, with cluster sampling, I'm going to say, okay, I'm going to randomly select Mr. C, Mrs. G, and Mr. J. All right, and I'm just going to go to their homerooms. I'm not going to Miss A's homeroom. I'm not going to Miss B's homeroom. I'm not going to D's homeroom. I'm not going to E's homeroom. I'm only going to C, G, and J. All right, so I've just randomly selected those. Those aren't special in any way. I've just randomly selected those. All right, then I go to homerooms C, G, and J and survey or sample every student in those homerooms. Okay, so let's think about the differences between the two. With stratified sampling, I'm going by and I'm visiting every subgroup. With cluster sampling, I'm randomly choosing some of the subgroups, but I'm surveying everyone that's in that cluster. Okay, so for stratified sampling, I was going by every homeroom, but I'm only picking a couple of people from each homeroom. In cluster sampling, I'm selecting a couple of homerooms or a few homerooms, and I'm surveying everyone every student that's in those homerooms. All right, so here's another example. Suppose that you randomly select 2 out of 10 sections of Math 1401, that's the class that we're in, so elementary statistics, and then we interview every student in those 2 sections. All right, so with stratified sampling, you would have went to every one of those 10 sections of elementary statistics and then maybe picked 2 or 3 students from each section. Whereas with cluster sampling, we're picking 2 of the sections and we're interviewing every student in those classes. All right, next we've got systematic sampling. This is a very unique style of sampling, and I think people typically catch on to this one very quickly. With systematic sampling, every nth member of the population is selected after some random starting point. This is really good if you have like a list of names or if you have like a line of people. So maybe you have like a ton of people lined up outside of a movie theater or outside of a sporting event. All right, so you randomly pick a starting point and then maybe you survey every 7th person or every 14th person or every 50th person, okay? All right, so here's an example. You survey every 10th person who enters a CCGA basketball game starting from a randomly chosen individual. So maybe you just show up, you know it's not the first person who's entered, you're not going to start with the first person, you're going to randomly pick a starting point, and then after that first person, you're going to survey every 10th person who enters the basketball game. Our last sampling method is called convenience sampling. This is where samples are just taken from a group that is easily accessible to the researcher. While this is easy, it can introduce bias. Right? So if you just survey the people that are the most easily accessible to you, you're not necessarily getting a representative sample of your population. All right, so here's an example. Miss Berry wants to conduct a study on elementary statistics students in Georgia, but she only surveys the students in her class. All right, so we're not capturing information about, students that are at larger colleges, students that are at smaller colleges. All right, so if we just survey the students that are in my class, we're limiting ourselves and not and potentially not including, all of the voices from the population that we need to include. All right, so let's look at some examples. Determine the sampling technique used for each of the following studies. You poll each member of the group you wish to study. All right, so this is actually one that we didn't talk about today, but we did talk about it in the last, or maybe the first section, section 1.1. What is it called when you survey every member of your population? That's called a census, right? That's where you survey every member of the population. All right, so a census is where you survey every member of the population. All right, so sorry for the trick question first. Let's look at one that we actually talked about today. A school administrator chooses 20 people at random from each math class. All right, so let's say that we've got, 5 math classes. We'll call them A, B, C, D, E. We're going and we're picking 20 people from A, 20 people from B, 20 people from C, 20 people from D, 20 people from E. All right, so what type of sampling would that be if we're going to every subgroup and choosing a few people from each subgroup? That's going to be stratified, right? Stratified sampling. All right, cluster sampling would have been like maybe we choose 4 math classes and we survey everyone in those 4 math classes. Okay. Next, we have a market researcher randomly selects 2 neighborhoods in Brunswick and then distributes a survey to each house in the 2 selected neighborhoods. All right, so we've got much more than 2 neighborhoods in Brunswick, right? Right, so a market researcher has randomly selected two of those neighborhoods and then surveyed every house in those neighborhoods. What type of sampling method would that be? Cluster sampling. Right, so that's where you are randomly selecting a couple of subgroups, but then you're surveying everyone in those subgroups. Right, so to determine who will win a free meal, the cashier at Michael's Deli draws a business card out of a box of entries. Right, so this person is just reaching their name into the box and pulling out a business card. So what type of sampling method would that be? Just reaching your hand into the box and pulling out an entry would be simple random sampling. Everyone has an equal chance of being selected. All right, and then the quality control department at Pepsi measures the weight of every 10th bottle off the assembly line. That's systematic. Every nth bottle is being selected, every 10th specifically in this situation. All right, so more on experimental design. So this is two variables that people often struggle with remembering which is which. So we've got your book calls it the response variable and the explanatory variable. Some books will call it the independent and dependent variables. All right, so if you want to think of them in those terms, let's see, your response would be your dependent variable. The explanatory variable would be the independent. So the response is going to depend on the explanatory variable or the independent variable. All right, so it says, suppose that you're a researcher who wants to design an experiment to determine if using Chantix reduces a person's urge to smoke. The use of Chantix is called the explanatory variable. That's what's going to explain whether or not a person's urge to smoke is reduced. All right, so the urge to smoke is called the response variable or the dependent variable. The urge to smoke is going to depend on the use of the drug. All right, so let me write that down. The urge to smoke depends on the use of the drug, Chantix. All right, so your response variable is going to depend on the explanatory variable. Response variable depends on your explanatory variable. The people who participate in your experiment are called the subjects or just the participants. To start, whenever you are setting up your experimental design, you're going to start by splitting your subjects into two groups. We have the treatment group and the control group. The treatment group is going to be the group that receives the treatment or whatever intervention is being studied. The control group does not receive the treatment or intervention. These people are used as a benchmark to compare the results of the treatment group. So this is sort of like your baseline. So think your baseline. So basically, if a person just says they want to quit smoking, they're going to go cold turkey, how likely are they to be able to quit? The treatment group is going to be, okay, if we give these people the Chantix, is it going to reduce their urge to smoke? Right, so treatment group receives the treatment, control group does not receive the treatment. Now, sometimes whenever you split your subjects into two groups, you might observe something called the placebo effect. All right, so keep in mind that these people, your subjects, they don't know who's getting the treatment. The subjects in the study, do not know. Who's, is that the right who's? I feel like it's supposed to be apostrophe S. Getting the treatment. And in this case, specifically the Chantix. All right, so both groups are going to be getting a pill, right? They don't know who's got the real Chantix and who's got the, sugar pill or the placebo. All right, so sometimes when we design experiments, we can observe something called the placebo effect. So let's talk about the placebo effect. The placebo effect occurs when individuals experience real changes in their health or behavior after some treatment that has no therapeutic effect. So they're just taking some sort of placebo, some sort of sugar pill, but they observe real changes in their health or their behavior simply because they believe that they are receiving an active treatment. So this is the power of your mind in changing and experiencing real changes in your health or your behavior. So a couple of famous occurrences of the placebo effect. In the treatment of pain, in some clinical trials, patients were given a placebo, such as a sugar pill, instead of actual pain medication, and in many cases, patients will report experiencing pain relief, even though they're just taking a sugar pill. So their belief that they're taking a real medication tricked their brains into thinking that their pain was reduced. Another example is that sometimes a athletic trainer may tell an athlete that they are receiving some sort of performance enhancing drugs. It's actually a placebo, and despite the fact that it's actually a placebo, they may observe improved performance in the athlete. And then another place that I've seen in the placebo effect recently is in that I think it's called like KT tape or something. You see a lot of the athletes wearing this, and supposedly some of the effects of the KT tape are totally from the placebo effect, that the athlete just feels that believes that they are being better supported through the use of the tape, and as a result they have less occurrences of injuries. All right, so we talked about how in the Chantix experiment that the participants don't know who's receiving the treatment. In some rare occurrences, the researcher may also not know who's receiving the treatment. That's called a double-blind study. So a single-blind study is what we just talked about with the Chantix. That's where if the researcher knows which subjects are in which group, but the participants do not, and if the researcher nor the subjects know who's in which group, that's called a double-blind study. So in a double-blind study, you have some third party who keeps track of which participant is in which group. All right, so an example of this, I did a double-blind study when I was in graduate school with beer brewing. All right, so I had, let's say, 10 growlers, which is the jug that you brew the beer in. I had 10 growlers, and then I had maybe 5 treatments that I was applying to those growlers. I didn't know which growlers had received which treatment, so some of them received stuff like yeast, some of them received stuff like some sort of artificial fermentation booster or enhancer. Some of them received nothing. Some of them received some type of acid. and I can't remember what the last one was, but my advisor, sorry, I got cut off there, but um, my advisor kept track of which growler received which treatment, and then that way I was not biased when I was collecting the data. Okay, so let's look at an official example. You are a researcher performing a study on a new drug that's designed to lower blood pressure. Individuals with high blood pressure are selected for the study and then divided into two groups. The subjects that are in Group A will receive the pills containing the real drug, and then the subjects in Group B will be giving a placebo. All right, so the explanatory variable, remember this is what is explaining the change. This is your, this is going to be your treatment. All right, so in this case, our explanatory variable is the use of the new drug. All right, so think of your explanatory variable as the treatment or intervention. All right, next, what is the response variable? What is the outcome of using the drug? That's going to be your blood pressure, right? Hopefully we're going to have lowered blood pressure. All right, which group is the treatment group? Which group is receiving the real treatment? Group A. Group A is the treatment group because they receive the real blood pressure meds. Which group is the control group? The control group is the one that's getting the placebo. That's group B. All right, so group B is the control group because they receive placebo. Sorry about my handwriting and my spelling. All right, single blind or double blind? We have no evidence here that the researcher does not know which group the participants are in, so we would say this is a single blind study or a single blind experiment. So there's no evidence, there's no wording in the problem that would lead us to believe that the researcher does not know which group the subjects are in. Number 3, our last question. Suppose you're a researcher working for Planet Fitness. You're tasked with determining if offering more fitness classes helps to keep clients registered longer at the gym. All right, so if you offer more fitness classes, will you keep clients registered longer? 500 current clients are chosen at random to participate in the experiment. The participants are split up equally into two groups. The people in group 1 are offered 2 extra fitness classes, so they're getting the intervention or the treatment. All right, so that's our treatment group. And the participants in group 2 continue to have access to the same number of classes as before. All right, so that's our control group. After 6 months, the number of participants still registered from group 1 is compared against the number of still registered participants from group 2. What is the explanatory variable? All right, so remember, the explanatory variable, that's the treatment. All right, that's the treatment or the intervention. Sorry, I lost my mouse button. There we go. Oh, goodness, there it is. Okay. All right, our explanatory variable, this is like the intervention or the treatment. It's what's explaining the change. All right, so we're hoping that if we offer more fitness classes, that will keep people registered for longer. So the number of fitness classes offered is your explanatory variable. So were you offered just the regular number of fitness classes, or were you offered extra classes? So the number of fitness classes offered. Our response variable, that's going to be what the change. What was the change? So the treatment was the number of fitness classes offered. What were we hoping that would have an effect on? All right, so we were hoping that if we offered extra fitness classes, that it would keep clients registered longer. All right, so that would be the number of participants that are still registered after 6 months. All right, so we're hoping that offering those extra classes is going to keep people registered at the 6-month time. All right, which group is the treatment group? I think we already mentioned this. The people that are receiving the treatment, this is people in group 1. So they're getting the extra classes. All right, so group 1 is the treatment group because they get access to extra classes. Our control group, that's the people that everything remains the same. All right, so that's going to be our folks that were in group 2. All right, so why is group 2 the control group? Because they are not offered any extra classes. I feel like I spelled offered wrong. All right, so group 2 is the control group because they did not get the extra classes offered to them. All right, and then our last question, is this a single blind experiment or a double blind experiment? There's no wording in here anywhere in this problem that would lead us to believe that the researcher, which is us, that we did not know who was in which group. So since there's no information that would lead us to believe that this is a double blind experiment, so we can assume that this is a single blind experiment. All right, that is everything for chapter 1, which was sort of our introduction to the vocabulary and a little bit of a preview of, what the semester will look like. If you have any questions over chapter 1, please let me know, and I'll see you guys next time.